section formula, internal section formula. If A and B vector are the position vectors of 2 points A and B respectively, and point C divides the join of AB, it is from A to B, so it is vector AB. So if point C divides the join of AB in the ratio m is to n, then show that the position vector of point C, that is OC vector, is MB vector plus NA vector divided by m plus n. Now, this is the derivation, and this is very important if you really want to be thorough in your vector portion. So they're saying that there is a vector AB and a point, this is vector AB, and there is a point C which divides the segment in the ratio m is to n. This is what the question is saying. Now, we are interested in point C, and we have to prove that point C is MB plus NA divided by m plus n. Now, by using a dotted line, I'm showing that OB, this is B vector, OB is a B vector, and I'm showing OA is an A vector. And my target is obviously to prove that OC is MB plus NA divided by m plus n. Now, according to the situation, according to the question, what is the ratio of the segments? The ratio of the segments is m by n. So the ratio of the segments is n by n, takes you to the situation that AC vector is somewhere m by n times of CB vector. If the ratio is like this, then obviously vectors will be in this condition, because as you take their magnitudes, then magnitude of AC divided by the magnitude of CB will be the ratio m is to n. So if this is the condition given to us, then this will be the situation with the vectors. I repeat, if this is the ratio given to us, then this should be the situation with the vectors. So now, after connecting this, one could further write that n times of AC vector is m times of CB vector. Now, we have the idea of formation of a vector. How can we form AC with the help of two position vectors? So AC can easily be formed with OC minus OA, and same way CB can be formed as OB minus OC. Now I can put the value of, keeping OC same, I can put the value of OA as A vector and OB as B vector. Now it is only a case of expanding the brackets and then collecting OC, because OC is a target. Now you could see that n times of OC plus m times of OC is, and we are getting closer to the result by taking OC common, OC vector common. One could get that OC is MB vector plus NA vector divided by m plus n. You can underline it, or you can put in a box that OC vector is MB vector plus NA vector over m plus n. Midpoint formula. All of us, we know that section formula, rather internal section formula, is OC vector is equal to MB vector plus NA vector divided by m plus n. And you know the diagram, it is AB, segment AB vector, and point C somewhere in between cuts it in the ratio m is to n, and then with the help of position vectors, you remember this OC vector became MB plus NA over M plus N. Now imagine that if M equals N, as M equals N, this is the indication that C is a midpoint. And the two are correlated in the sense that if C is a midpoint, automatically M is equal to N, or if M becomes N, C becomes the midpoint. So as C becomes the midpoint, if C becomes the midpoint, and if I place M in place of N, formula becomes and hence A vector plus B vector, A vector plus B vector divided by 2. So if C is the midpoint of two position vectors A and B, then OC is given by A vector plus B vector divided by 2, or obviously B vector plus A vector divided by 2. Section formula, external section formula. If A and B are the position vectors of 2 points AB respectively, and point C divides the join of AB vector, the direction is A to B, AB vector externally in the ratio M is to N. When we say externally in the ratio, it means the point will be on the line, but it will not be on the vector AB. It will not be on the segment, but surely it will be on the directed line. Then show that OC vector is, that is the point C is MB vector minus NA vector over M minus N. So if you have done internal section formula, then you have probably the little idea. Otherwise, we can draw independently, and initially it will be a segment, but the point C will be outside. This is A, this is B, this entire ratio is M, this entire ratio is M, and this is N, and this is the target point C. So let me convert this into position vectors first. These are the position vectors. It is good to draw them, but there is no compulsion at all. Now once again, what is the condition given to us? The condition is that AC, magnitude of AC, because it's about ratio of segments of parts, it's not about vector at all. So mod of AC and mod of BC is in the ratio M by N. If this is the condition, then vectors will surely be obeying that AC vector is M by N times a BC vector. You can also take point C in the direction of on this part, but we'll always take the direction AB because it's given in the question. But you can take point C anywhere. It is not always that it will be nearer to B. It could be anywhere, but it has to be on the line. The 3 points are collinear. Back on to the condition and the situation that AC vector is M by N times a BC vector, that is N times AC vector is M times a BC vector. Using the concept of position vectors, I can take AC vector as OC minus OA. This is OC minus OB. I can then replace OC with A vector and OB with B vector, and it is more of now opening the bracket and collecting the value of OC. by taking negative common. One could see, just see I've taken OC common from here. Right hand side is the same now, and I'll divide by the coefficient of OC vector to get the answer. So this is the external section formula. Therefore, OC vector is MB vector minus NA vector over M minus N. In case of internal section formula, this is plus, and in case of external section formula, these are negatives. But remember, in both the cases, the points A, B, C are collinear. Any section formula, whether it's a midpoint or internal or external, any section formula represents the set of collinear points.